Okay, my name is Vagif. I'm originally from Russia, but I've been living in Norway for 30 years, doing a lot of C#, currently doing more Fsharp than C#. How many of you practicing mostly object-oriented languages like Java, C#, C++? Yeah, vast majority. How many mainly use functional languages? Yeah, very few. How many tried functional languages? Yeah, also vast majority. Yeah, my GitHub nickname is Object, and my Twitter nickname is OOObject, and this is because object was taken and double object was taken, so triple. But it says something about my attachment, I guess, to object-oriented developer, and I really was for something like 2 decades. So I will try to talk about my path to functional programming, and one sort of disclaimer I need to make: that this is not something that I really sort of recommend you to do, even if you are happy with your current development environment and language of your choice. And who was on the previous talk by PJ Haggerty, I think he also had this message saying that you don't need to switch to anything which is trendy. I mean, you need to do your job, you need to be happy as a developer, and so that's quite important. That's probably most important. And there is a great blog post by Eric Singh. Eric Singh is quite legendary figure. He was one of the developers of first browsers. It was Spyglass, later to become like first version of Internet Explorer. And he's using a lot of Fsharp now, and a few years ago he wrote a blog post about Fsharp evangelism, where he said that just pure evangelism will not work if you try to address it to a person who is happy with what he's doing. You need to catch somebody sort of at pain, and he had this term pragmatist at pain. So people who accumulated some pain about what they're doing, and they're probably not particularly happy with some of it, and maybe they can consider to try something else. So very quick, just one slide about our product. I worked in a project for Norwegian Broadcasting Corporation, NRK. So we are doing we publish media files to be streamed, so you can understand, of course, you can figure out how important our service is. So they need to be like available, scalable, robust, and news clips published all the time. So this all is based on our practical experience. So let's start with something which is very simple and which any of you will implement just in a matter of minutes. Modeling a point in object-oriented languages like C#. And this is from, I took it with permission from a presentation by another Russian guy, actually, Dmitry Ivanov, formerly. He used to work on JetBrains. And in one of his talk, he was describing actually how hard it can be for, at least for newcomer, for a new developer to implement something really simple. So he came with this very simple implementation of class point, and many of developers will probably do it like this. That was a few years ago. With new features of C#, probably people would consider some modern features of C#, but anyway, it's pretty standard implementation. And if we look at it carefully, we will find that actually there are 5 lines of code, but 4 of them are, well, we can say they are wrong, and 2 of them are missing. Missing part is that if you want this to be comparable, you need to implement get hash code, you need to have equals, and then also if you need this to be thread safe, then it should only have getters, and all the dangerous methods which change the value, they shouldn't just change value in place, they should return a new instance of this object. So this is a sort of better, safer implementation, where you have only read-only members, safe methods, and a couple of methods which were missing. And this is how this can be done in Fsharp. As you see, this is default. I mean, the first implementation which comes to mind to either experience on new developer, and that actually works out of the box. This is how you create points in Fsharp, and this is how you copy them. Of course, you can say that, oh well, developers can make mistake, and then if developer is experienced, he can learn from first mistakes and then stop making them. I wouldn't call it mistake. I would maybe call it some sort of insufficient experience, because you have to gain some experience. It's quite natural to follow, to do things by default in the easiest way. And it's, in a way, it's not your problem as a beginning developer that you may have not learned all these tricks and details, how you do it thread safe, and why do you need get hash code, and so on. And but I think this is actually principal difference between OP and FP. With this mainstream object-oriented languages like Java, C#, and C++, you have a variety of choices. You can really make things as powerful as you want, but that's your sole responsibility. You can also go wrong. While with many, or at least most known functional programming languages, they give you some safe set of default choices. And why is it important? Can we say, okay, we as sort of C# developers, we can learn, we can become better? I think that we shouldn't underestimate importance of code to be minimalistic, clear, and for default implementation to work out of the box. There was a great talk by Robert Smallshire. He often in his presentation addresses some metrics of software project, and then he looked at half-lives of software-related entities. And so half-life of developer in a team is about 3 years, which means that within 3 years, half of developers in a project team will be gone, which is probably, yeah, I think it fits sort of my experience. Then half-life of application time is 6 years. It's actually double. It's longer than developer in a team. And then, but what really surprised me, that half-life of lines of code is about 13 years. So it definitely contradicted my personal expectations about us developers being in charge, like changing things around, code lines. It's actually a bit the other way around, like lines of code like stones in the wood, say, sort of lying sarcastically watching us coming and going, because it's 13 years. It's based on analysis from mainly some large, as far as understood, enterprise project, but still. So I think what message these metrics can give to us is that we should care more about how our code will look for the sake of the next developer, because more often than not, it's not us who will deal with our own technical debt. It will be different people. So we need to keep code succinct and keep it code clear, keep our intentions clean. And in this respect, I think that so moving towards functional programming gave us cleaner code and cleaner intentions. That was part of my personal point of pain when I was working with C# and with C++ before that. It was a lot of ceremony. Now less with new version of C#, I must say. But that for me was one of the reasons why I started looking at functional programming. Functional programming also is a path to concurrency. Languages like Java and C#, they will be mutable by default. whatever happens to them. They're mutable. Data structures are mutable. Again, what you get by default in functional languages, they're immutable. Data structures are immutable, and the price for this is actually very high for having mutable data structures, because then you need to log them. You need to program to take be in charge of sharing data and placing locks here and there, and locks do not compose. What does it mean? Is that if you have a component, small component, where you carefully plan your locks, and then you build a large application out of it, unless you place locks making serializing everything, which makes things will be really slow, you will need to rearrange and regroup these locks. It's very hard to test, and it's not something you can just build into every component and then magically all your locks will start operate with coordinate with each other. And the consequences of misplaced locks, of course, it can be dead locks, but if you place them safely with too much safety, then you will be victim of so-called Amdahl's law, which tells you exactly what is the price you pay for non-parallelized code. And actually the price increases very rapidly. So if only 40% of your code can be parallelized, then you can increase your number of processors by 10. And with 10 times more processors, your performance only will increase by 56, about 50%. So it's it really sounds strange, but this is a price you have to pay. So if much of your code is not parallelized, then there is no need to increase number of CPUs. So that is also a pain point for us, which led us to functional programming, because we were working with application that needed to handle parallel threads and a lot of data in parallel. And with our current system, you won't find words like lock or thread in our source code. This is also partly because of the actor model. I will come back to that. But let's move on to business objects. So this was a correct implementation, as we saw, or sort of more correct than the first one. But we forgot one thing. We forgot visibility here. So actually, we need to place visibility, which is well, is it public or private? Of course, you have things like internal protected, but for the external client of your source code, it is visible on net. So you have to make public everything which you want to be accessible. And after having worked with functional languages, I question the poverty of available choices here, because you have some safe method, something like get x and y properties, but you have some sort of dangerous methods, which maybe you only want them to be available in some scenarios where you can edit the point, can modify it. Otherwise, you don't want to make it visible. And then, okay, how are you going to achieve that? So you have scenario where you mostly view points, and also you have some exceptional scenario where you need to edit points. And I hope you will not go that path, creating point and then editable points, which inherit from that, because that's just in the end it will be a nightmare to have something like this. So another alternative is to have some sort of point manager. So you have a point without any operations, any method that modify it, and then you have point manager which actually modifies it. But this is essentially, then you will abandon point as a business object. So all what we said, or what we used to say about business object, that it's a harmony of data and operations. In this case, we actually need to split the things. So this is how we do it in language Fsharp. You have data separately, and then we define modules where we visibility of the module, it can be different for different clients. So here we have how we can increase point, and then we can have a model point update if you don't want this to be visible, and it only you need to explicitly open this module to have this method available that change the point. So this is how we work nowadays in our project, and I almost completely agree with what Armstrong, creator of Erlang, said once, that data and operations are them. They are so different animals that they don't really belong to the same cage. So we really need to separate them. And this is mostly in our project. We have data as a plain data and operation them placed in modules. So continuing with business object. So business object, when they were introduced, they were presented and still presented in universities as a harmony of data and operations on them. There is some sort of holy cow. Everything cooperates peacefully and friendly. And in the projects where I worked, specifically, especially large projects which lived for many years, then picture was more like this. You have this data, and by the way, it's a painting by famous Russian painter Ilya Repin. This is a river Volga, and this is around beginning of 20th century. So you have this object which actually has nothing to do with operations on them, but they need to drag these operations, but they don't have any personal interest in that. And to illustrate with some examples from real code, there is a great book which I recommend you to read, even if you don't do Fsharp and don't plan to use functional programming. Who read Scott Wlaschin's book? Yeah, few hands. Please read it if you can. It's really motivating or thought-provoking. And so he shows, using examples in Fsharp, he uses order processing as as domain, and he shows how you can trace the order from being unvalidated to shipped or cancel it. And if you try to do something in C#, there are several options to do that, but again, one of the simplest and maybe default is that you have class order, which has some properties. Then you have some read-only methods like isValidated, shipped, cancelled. And then you have some methods, validate, ship, and cancel. And here, because we mix data and operations on them, there is a highly subjective choice. Can an order validate, ship, and cancel itself? Or should it be some order manager doing it outside? Who thinks that, who would go that path? Like it's okay to have validate, ship, and cancel in order class? No hands. Who would place these methods in a different class? Yeah, most of you. You know, I've seen both, and I think with more experience, developers come to this. But you will find, like if you look at the code, source code of the project that lived for a few years and was maintained by variety of people, you will find all sorts of subjective decisions about what method to put inside the class, on what to take outside. And maybe validate and ship, it's a bit obvious they should be placed outside. But there may be more methods in question. And if you look at these two classes, actually we abandon business object per se, because we have pure data and we have pure business. So actually, while we're talking about OP and business object, but we really separated them here. And if I go back to C# development today, I would probably create several classes, like a new class for each order processing stage, like unvalidated order, validated order, shipped order, and so on. And then I will create the managers which take input of one class and return inputs of another class. So I can do this pipelined data processing. Who would consider that path? To have small classes for each order processing. Yeah, some hands. Who think that one order class which fits all stage processing will be sufficient? Yeah, also some, maybe fewer hands, but also some hands. Yeah, I'm biased because I've been to Fsharp and functional programming, where what we do typically, we have very small classes where types, this is called a record type, and so we for each processing stage we have its own type with just data that are available that makes sense on this stage. Then we have module for order processing, which transform this data. So finally, the order processing workflow can be written like this. So it can be understood actually even by non-technical people. So we have we create some order, then we pipeline it to next stage, validate order, price order, and ship order, and there are all different types on each stage. Again, with you see that it's quite compact code, and it's a sort of default choice which comes in mind, and that sort of things that works best. Another thing which I think is quite important, I didn't realize how important it is until I started writing Fsharp. It's so-called algebraic data types. You have record types in Fsharp which are very similar to C# classes, or like new in new C# also records, but you also have so this is first type. Sorry, I'm back. Yeah, so these are so-called product types because it's a product of different properties, and then you have some so-called sum types. It's either or. Payment funding source is either payment card or bank account. You can't do such easy expression of some types in C# or Java. You will need to start using some interfaces, but it's really makes it very compact DSLs where you can describe your domain in a relatively simple form, which will be understood to everyone. One other thing that is often mentioned by people who start working with functional programming, and that in functional languages typically you don't work with nulls. You have option, you have maybe various names, but it's the same. It's sort of optional type. What I find, and we saw in our project, that just mechanical switch from nulls to options can be almost as bad, because the problem with nulls, often they represent some design flaws. So why should be null here? If we have a user that hasn't fully registered, why do we have same type for registered, non-registered users? Let's split them. Unregistered user without name and a registered user with name, something like that. So we every time we work with optional types, we actually try to analyze. Maybe we need to split our scenarios, and then we'll have more types, but more strict, more tight domain model. And there is a great blog post actually which has been popularized by many speakers and developers since then, by Yaron Minsky, about make illegal state unrepresentable. And this is actually about nulls and options. So you should you should only have things that it's possible to combine in each processing stage, and you should not leave some outside knowledge of what data compatible, what data can be mixed together, what not. Everything which you can mix with valid types should be possible. What not possible shouldn't be representable. And algebraic data types are very good at that. So Yeah, so optional values, of course, we can't live without optional values. When we read things from database, when we get things from external services, it's fine. We can't live without it. But as long as we import them into our domain, then we should be very strict about what is possible and what is not. And if you want to hear about more reasoning about why you should be careful about optional types, there's a great talk by Rich Hickey. He's a creator of Clojure language, and it's a 1-hour talk which is called Maybe Not, where actually he attacks this non-mandatory data in our domain. So, but can't we really adopt everything FP style in OP language like C# or Java? And what you will see that more and more traditional object-oriented languages, they present themselves as multi-paradigm. You will find the statements about Java becoming multi-paradigm language, Kotlin, C# nowadays, even C++. A couple of years ago, on C++ conference, there was a talk by Phil Nash about object-oriented considered harmful. Imagine this talk 20 years ago on a C++ conference. It's a blasphemy. So it just wasn't possible at all. And what he presented in his talk, this all well known from functional programming area: persistent data structures, monadic operations, functionally composable algorithms. So this is using of pipelines. So mainstream OOP languages actually go that path. So it's a very good and valid question. Why can't we just stay with C# or Java and do things in a hybrid way, mixing object-oriented principles with functional? And of course we can. But this was from short Twitter discussion. It was after C# got another feature from Fsharp, and then one developer a bit unhappy about it. That why import all this to Fsharp, and then he got an answer from Mats Torgersen, who's one of lead C# designers, who actually he's responsible for many of these new features of C#. And then he said that we do our best to add these FP features seamlessly to C# and make them first class. That said, if you want the full functional experience, Fsharp is a great choice. And coming back to these metrics about that developers living shorter lives in teams than lines of code, I'd say that if you really want your code to be succinct and you lean towards functional programming, you're really interested in that, and you think it eliminates some of your pain points, you can try going that way, that full way. And one important, of course, reason is that mutability. So C#, Java, they will always be mutable by default, depending on how important for you the parallelization, safety of data, get rid of logs. Mutability can be one of the factors when choosing what language to use. And what also I find it important to add when we talk about object-oriented languages, it's a funny thing. I think Alan Kay, he is also speaking on this conference, correct? Yeah. So this is awesomeness GOTO. So some legendary speakers, you can find them here. So he is considered to be inventor of object-oriented term. And what he said, that when he invented OOP, he didn't have C++ in mind. And when he says so, we can say that also he didn't have in mind neither C# or Java, because they follow at least in OP part principles of C++. And what he had in mind when he invented OP, it was mostly message-based communication between objects. So and so he had in mind actually more or maybe closer match to real world. because this is how actually things happen in the real world. So we get, using our receptors, messages from the outside world, and we respond to them. And if you look at how traditional classical OOP languages implement methods, then it's somewhat strange to me that I find it very fascinating when I was learning C++. It was even before C#. So I found, oh, this is so nice. It's so understandable. You have a class dog, which inherits from mammal. Okay, this part of inheritance, nice. Dog is mammal. Then it has name, and then you have a void bark method. So actually, I can call this method, and the dog will bark. Woof woof, or depending on who the dog buys from which country, it will bark maybe differently. But what we're getting actually here, if we look at how this all works, this is what kind of model we have. So dog doesn't really bark by itself. We have to actually draw some strings. So it's a client who barks the dog. Isn't it strange? Because when I look at this concept of how OP languages work, is that it finds me really strange that I was really fascinated and find that reflecting the real world, because it doesn't reflect the real world. I have a dog, and well, maybe if I say bark, he will bark. But if I say don't bark, no, it's not because of me. He will get message. He will get his own conclusions out of it. So the entities, the physical entities, they can get our messages, but they process them, and they make their own decisions, and they may respond or may not respond to what we tell them. So this is why I think it's quite artificial and not representable with respect to real world. And if you look at OP, how Alan Kay meant it, and some people say that actor model, actually it's OP done right. So you have actors, which the only way to communicate with actors is to send them messages. And actors are very simple. They're single-threaded. They get your message, and they will think what to do with it. They may send some message back. They may send message to other actors, but they have sole responsibility of what they will do with external information. And for us, actually, it was a very great combination of using functional languages at a smaller scope, where we have functional transformations of data within the thread. And if we want to arrange communication between objects without thinking about starting threads, coordinating threads, then we use actors that exchange message one another, and it's extremely performant because it's reactive software. So when actor is sleeping, when actor doesn't get message, it's just sleeping. So it doesn't consume CPU, and you can say millions of messages a second between two actors, and like actor with very little code consume just few hundred bytes of memory. So this is how we do it. So to summarize what we came to after using OOP for, I was using it for a couple of decades. Some of my colleagues used it shorter time, they're younger. But what we doing now in our project, first we appreciate using algebraic data types because they keep our domain model tight, compact, and relatively easy to understand, even for newcomers who just coming to the project. And that's important, to care about inexperienced developer who will replace you. Then we are quite critical to use of nulls and options. So this principle by Yaron Minsky about making illegal states unrepresentable, it's quite important. And you can follow this principle no matter whether you do it in Fsharp, C#, or C++, any language. This is something which I highly recommend to use. Then we use modules where we place our operations, and visibility of these modules, actually it's a visibility of operations. So we don't expose unsafe operations without needs. So we don't have this quite binary public-private visibility classification between operations. And this is not part of FP, but it really plays very well with functional programming. Communication between objects that are based on the actor model. So this is how we do. We're using akka.net, which is port of akka from Java world, in Java and Scala. So that's probably the main summary from my talk. And for our stakeholders, I think I don't have any metrics, unlike Robert Smallschreiber, who had concrete metrics about software project. I don't have any metrics which would show that how it shortened path to production. But we and our stakeholders, our management and people around us, I think we observed that we're quite responsive to quick changes, and code is much more compact. And in Fsharp, typically when we make some changes, you may spend a few hours to make new things compile, but after it compiles, it just runs out of the box. It doesn't need mean that you don't need to write unit tests. Of course, you need to write unit tests. But what we observe regularly is that it's so strong type checking that if you write your types properly, then you guard it very well. So yeah, with this, I think we have some time for free questions. If you need to contact me, you can do it by these communication channels. And of course, don't forget to vote for this session in the GOTO app.